Okay, 2.3, so quadratics and factorising, really important topic because you need to be able to factorise quadratics to pass this course. So we're starting quadratics this week, and next week we're going to go on to sketching them, moving them around, and some other interesting stuff. But today it's just kind of GCSE recap, how do you factorise quadratics? So the three types of quadratic mainly, you'll have seen this one before, lots, you might not have seen these two as often. So we'll go through the methods to factorise them now. So the first type is when you've got a common factor of x. Because we've only got two terms, both those terms have an x in them, we can take out a common factor of x squared plus bx. So both terms have an x, so pull that outside the brackets. We're left with an x and left with a b. There you go. So for a numerical example, we might have something like 2x squared plus 6x. So here we've got a common factor of not only x but a 2 as well, because both 6 and 2 have a factor of 2 in common. So 2x comes outside the brackets, we're left with an x and then plus 3. Okay, second type is what we call a difference of squares, or difference of two squares. This comes up all the time in our exams, so try and remember this one. Two square numbers subtracted from each other can be factorised. So for example, x squared minus b squared factorises like this: x plus b, x minus b. Which is similar to what we were doing when we were rationalising denominators in the last video. So if you times these things together, notice all that's different is the sign has changed. If you expand those brackets, the bx terms that you'd expect in the middle disappear. Ooh, that's gone horrible. Okay. So yeah, the bx terms in the middle disappear because you've got plus bx minus bx. So if you spot this, that's why, and that's why it factorises to that. So for an example, you might have 4x squared minus 16. Notice everything there is a square number. So that will factorise to 2x minus 4, 2x plus 4. And really quickly we can just show why that works. If we expand it, 2x times 2x, 4x squared. 4 times that is going to be minus 8x. 4 times that is plus 8x. And then minus 16. So you can see the middle two terms, plus 8, minus 8, cancel, leaving us what we started with. One more example of this one also works when you've got numbers to the power of 4. So you could have x to the 4 minus 16. Now both those are square numbers, but they're also numbers that are to the power 4. So you could have x squared, if you square root that one. And we could have 16 square rooted, which is 4, so plus 4 minus 4. Then we go on further and split that up because that's still a difference of two squares, but I'll leave that for you guys to have to mess around with. Okay, the last type, number 3, is a classic quadratic, so I'm going to clear the board for this one. Okay, so the standard kind of classic quadratic, and it can come in several different types. So the easy type, which you guys probably always hope for, is one like this. And you know it's going to split up into two brackets. And the trick is finding two numbers here and here that multiply to give 2 and add to give 3. So you can think two numbers that multiply to give 2 and add to give 3. If you want, you can make a little list of them. So I can only think of 2 and 1. So it has to be 2 and 1 really. 2 and 1, add to give 3, multiply to give 2. Won't always be that easy though. So we've got x plus 2x plus 1. And it's always important to check. So multiply out again, x squared plus 2x plus x plus 2, so x squared plus 3x plus 2, so correct. Always multiply out to check though. Now, the ones that students find more difficult are when you've got a number in front of the x. So let's try something like that. So it's the same idea, it's just a bit more difficult. So if I put my brackets up, the difficulty now is we've got kind of two unknowns in each bracket. These two have to multiply to make minus 10. And these two have to multiply to make 6x squared. And we also know this times this plus this times this have to add together to give 11, or minus 11. So there's a few ways you can do this. There's the brute force way, which I'm quite a big fan of, is write down all the factors of minus 10 I can think of. So we've got minus 10 and 1, or 1 and minus 10, or 2 and minus 5, or minus 5. 2, or signs could be the other way around. And here we can think of all the factors that might make 6x squared, 6x and x, or 2x and 3x. And then basically just trying them, thinking them through your head until you get the right kind of set. So for this one, it's going to be 3x plus 2 and 2x minus 5. Okay, now there is another method. If you're not keen on kind of going through the factors yourselves and thinking about it, kind of logically going through each step, there is another way to do it. So if you don't like that, you're welcome to try this other method. And if you don't like the other method, you're welcome to go back and use this instead. It's up to you guys to use whatever method you find easiest. So the other method, factorising quadratics, is find two factors of AC that add to B. So I'm talking about A, C and B here. So A times C is 2 times minus 3, which is minus 6 in this case. And B equals 5. So we need two factors of minus 6 that add to give 5. So have a think of what we could have. And the obvious ones are 6 and minus 1. We might have said minus 6 and 1, but they don't add to make 5, they add to make minus 5. So that's our first step. Next step is rewrite B term as a sum of these factors. So we're going to rewrite the B term, which here is 5, as a sum of 6 and minus 1. So basically we'll say 2x squared still, plus, or we'll do the other way around actually, minus x plus 6x minus 3 equals 0. So our equation is still the same as before. We've just, instead of writing 5x, we've written minus x plus 6x, which if you do the maths, there actually does equal 5x. And the last step is factorise pairs of terms. And to do this, you might need to adjust the order of x's. So we're going to factorise these. I've put them in the right order already, that's why I kind of changed it just now. We're going to factorise these two terms and factorise these two terms. So we get x as a common factor of these two. And here we've got a common factor of 3. There we go. And then we're left with this common factor which we're going to take out as well. So we're going to factorise this bit too. So 2x minus 1 x plus 3. And that is the factorised form of our original quadratic. Follow that through a few times if you want to try this method. It is good. I think it does take a little bit more time, whereas the other method you can quickly spot factors. So it's good to use both of them. It's good to be aware of this, but try the other one because it will get you better at spotting factors straight away. Alright, let's try one more method then. So if you guys want to try this one using whichever method you prefer, go for it. So I'm going to use using that new method. So AC equals minus 24. And we need factors of minus 24 that add to 10. So 12 and minus 2. So then we're going to rewrite it, remember, 3x squared plus 12x minus 2x minus 8. Then we're going to factorise this, so we get 3x, x plus 4, and then minus 2x plus 4. Excellent, so we've got the same factors, so we don't need to do anything else. So we get x plus 4, 3x minus 2. Excellent, right, that's factorising quadratics. Go over that a few times. The quiz is pretty long but pretty straightforward for this topic because you're just going to do a load of factorising. But this skill's really key, so make sure you can do this because it's going to come up all over the place throughout the A-level. Remember, you can also use your calculator to check these with its factorising quadratics